Hello.
Hello.
How are you?
I'm good. Hungry, but good.
Yeah. Oh, I just had lunch and it was so weird. Okay, so I got one of these little packs or whatever, right? And it was like cauliflower wings, right?
What?
So it's like breaded cauliflower or whatever. I just thought it'd be fun to try, like buffalo or whatever, right? And I just made it. It was like okay, like the cauliflower was good, but the sauce was too spicy for me. Hi, Will.
Why?
Anyway, I just thought it was like a really funny, weird thing.
That is weird.
Yeah.
Well, would you do it again?
Oh, dude.
Yeah, I have another one in the freezer.
Hello.
Hello. How's everybody?
Good.
Oh, you will. We learned all about HPV today in bio.
Oh yeah.
We love bio.
Mm-hmm.
I'm
Yeah.
just ready for this long weekend.
Amen.
We can make it the weekend already.
V.
We could make it the weekend right now, Mr. Sotelo.
We could,
I'm
yes.
just kidding, guys.
I'm
No,
not.
you're not. I'm not.
Yeah, I'm not.
Wait,
Yeah.
we were supposed to be kidding?
I don't know about this. No, we'll do some stuff.
Some stuff,
Some
but
stuff?
shortened. Because then we get the long weekend
Like maybe one or two problems, you know.
at most.
I'll pick some good ones then. Yeah, we can. We'll just do some practice on integrals.
Yay.
Woo!
And you won't have.
And now I can write it down though.
Nate, why do you never have a notebook?
Yeah.
What are you gonna do? when you
Excuse
have to
me,
do
right
it?
here. What is this, please?
Why do you never
just
write
look at
it?
Just look
When are
at
you
it.
gonna write it?
That's a good question.
Well,
I just didn't write anything last class because one, I
No.
was upstairs and I didn't want to go back downstairs to get my notes.
Nice.
Yeah. Great. Will,
All right.
Yeah, Nate.
what's up?
So yeah, one question. Do you guys finish your talks yet?
No.
No, I haven't finished. I haven't sent it to him either.
All right.
Oh, so you're slacking just as much as I am. Let's see.
Yeah.
What about you, Adrian?
Wait, do we have to have our PowerPoints done too for
No,
our
I
run?
think
I
that
hope
is
not.
in
That's not
February.
even started, so hopefully not.
Yeah, I hope not.
I thought they
I
said
don't
it's
think so. I
February
think
6th.
that'll be easy.
That's
Right,
what I think too.
Saturday, yeah.
Yeah.
Griffin, shut your
Griffin,
ears.
stop listening. Oh my god.
Well, we haven't said anything really.
Okay, he's good. He's good.
He heard enough to show you that you're talking about him.
Right, so anyway, I gotta sit down Saturday and get some of that done because I have not.
Well, I have 4 pages
Griffin,
done.
it's not what we actually do. We can't tell you what happens at Kairos.
Yeah, no, I have 4 pages done, and I was gonna add 2 more. And Will's like, Nate, you already have 1,600 words.
That's so many.
Yeah, I know. And he's like, you need about 2,000 for 20 minutes. I'm like, oh, okay.
Do you actually?
That's what he said.
I don't
But
know.
then I
if
looked
he
up
would yet.
online, and it was like 2,500. So I'm like, Will's a liar.
Once you get flowing, it's not that bad to write.
My
Well,
output's
okay.
good anyway. Like I've got a lot of fully written sentences in there anyway. But I just don't want to do it, and I have to.
Written sentences.
Yeah.
That was impressive.
No, it took me like an hour and a half to get the first page done. And then after that, I wrote 3 pages in under 2 hours. I was
Nice.
flowing.
Mm-hmm.
Nice.
That's the same rate though.
No.
You said it took you a half an hour to do.
No, I
one
said it took me
page.
an hour and a half to do the
I thought
first
you
page.
said half an hour to do your first page. and
I
then
could
you
not word the first page right. That's all I'm saying. Then it was flowing
Point is, I
water.
get it. And yeah, do we know about the PowerPoints? Are those?
Definitely don't know. So
You guys all ready?
maybe.
Ready for a weekend.
Well,
Enough Kairos, you guys.
No, more
We're gonna
Kairos.
go into this calculus song we're writing.
Oh, we could talk
Oh,
about that.
yeah.
That's it.
Can we
No
talk about
intro.
that?
I mean,
I
we were
really
talking
think we
about.
should do a rap. Like that's gonna be the easiest thing.
Dancing in the dark.
That's so wet. That's so wet.
Slow dancing in the dark.
Yeah, we could do
you
that.
just do it for inspiration.
The words start flowing like water. You might do more than one.
Yeah.
Yeah, maybe we write like 3
Right
songs.
plan, because it's calculus. Man, I don't know.
That's not good.
Well,
Nate can't write, but he can sing.
facts,
He's like Drake.
pretty much. Hey, my high pitch might be better than everyone's here. Maybe not Bella's.
It's true.
That's
I
not.
mean, we never heard Mr. Sotelo sing, so.
That's
Yeah,
true.
that's true. He might just be.
He might be me.
Let's do that falsetto.
Let's hear it.
I would break the internet.
Exactly, that's the thing. We're trying to set a trend. We're trying to be the #1 trending.
Yeah.
Or
All right. I say we do some problems.
Okay.
Alrighty.
I mean, you are the teacher, so I
are we
guess.
doing it from the same sheet?
Why do I not remember what Taylor series is?
We're not doing those, Bella.
No, are those easy?
No.
Are they?
Oh,
I
That-
Are
think-
they?
let's do some integration. That's still all fairly new.
I'm just gonna wait for you to present because I don't want to open my open math.
Yeah, I
That's okay.
can.
Martha, what you got there?
This is, that's a smoothie.
Nice.
Smoothie.
That kind of sounds good. I'm not gonna lie.
Did you guys see that Army Hammer is a cannibal?
Huh?
Who?
What are you talking about?
Well, you can't just throw something else like, oh yeah, my next door neighbor Anna Hammer, she's a cannibal. You gotta like give us something in the ballpark.
You Army Hammers.
He was in Social Network.
He.
The one Snow White movie with Billy Collins.
Or like the old one.
It's like a few years old, 2012 maybe.
Oh, then I'm definitely thinking of the wrong Snow White.
He doesn't call me by your name.
Oh yeah, maybe you've seen that. I don't know.
I bet you've seen it.
Probably, but I don't remember. So
You
All right.
Yeah, just
You
Google
guys ready?
it. Yes.
Anyway.
All right.
What the heck?
Are we on the? Wait, we already did that.
We're gonna do more integrals.
Griffin, you look so serious.
Her cat on live.
I'm just waiting
Azealia Banks.
52
Yeah.
minutes, and then I just gotta
I know
sleep.
she dug it up and she boiled it.
Wait, so why did they?
Oh, that's a lot of problems. Oh
sheesh.
my.
Oh, well, my.
We're not getting to them just yet.
Oh.
Vampire.
We will practice.
It's like
first.
messed up.
I don't know if we can do that.
They said that they don't think. Well, this thing says that they don't think it's true because they have like. There's like, who even accused him?
Well, it's Bella's word on your word, so
No, I'm just looking on this one site. This is just one site that says.
Because some of his
Okay.
ex-girlfriends came out and said that it was true.
what that? Oh,
If I were Army Hammer's ex-girlfriend, I would do that too.
I would never be Army Hammer's ex-girlfriend. I would just be his girlfriend.
Even though he's a cannibal, Bella. Not gonna let that get in the way.
Okay.
You ready?
Which sheet are we doing?
Maybe we should put them in a smaller
I'm making these
container
up right now.
so they don't take up so much. What are we on?
I'm just making up problems right now.
It doesn't
Oh,
really-
okay.
What if they don't have like nice answers though because you're doing this?
Yeah, how can we trust that?
Yeah, what if I don't trust you?
You just have to trust the process.
Very much don't.
I don't know about that.
Are we just gonna work through them?
One of the math memes I saw on the subreddit was, you know that guy's face where he's like happy and then he's like shocked.
Yeah.
The one where he's happy is like, oh, your answer worked out to a nice round number. And the shocked face was like, "Oh, it's calculus class."
So, okay, for this one, do we do the first or second method? I
Uh,
say
what do you mean?
So you have to like split it up because
because in the
it's
first one we just, like graphed them, you know, but in the second we did like
Oh,
the
yeah, this one we just used the second method. We're gonna
Dude.
break it up.
maneuver
Okay.
keeps calling me.
So yeah, we can do them turn by turn.
Wait a second. How come there's no like limits on this one?
Because there aren't.
Because it's better.
Oh, no.
So yeah, that's a little
Oh, that
different.
just sounds lazy.
Is that
That's a
my
little
open?
different. So what we're doing is we're not finding the area under the curve between two endpoints. We're finding the expression or the function whose derivative is the integrand. So we're taking the antiderivative as a function, and we're leaving it as a function. All right?
Sure.
So this is called an indefinite integral because there aren't definite bounds.
Right.
Makes sense.
All right. So how about the first term? Do you remember the inverse power rule?
Yeah,
Check your notes.
it's in here. Right here, right here. Okay, okay. So instead of xn yields nxn minus 1,
Mhm.
you have xn equals 1 over n plus 1x to the n plus 1 power.
Right, yeah. So the opposite of the power rule, instead of multiplying by the current power and then dropping the power by 1,
Mhm.
which is the derivative, you're going to raise the power by 1 and then divide by the new power.
So x to the 4th divided by 3.
No?
Oh shoot.
You're-
That's
you're
what I
wrong.
thought it was.
4.
X to the 4
Oh, so
over
third new power?
over 4. Oh, because it's n plus 1, right?
Yeah. So divide
Gotcha.
by the new power.
Okay.
Is that okay?
Gotcha. Yes.
4.
All right. So now we have the 2.
4.
That's a constant, so you can just pull it out.
And then x to the 3rd over 3.
Yes.
Yes.
Yeah.
And now remember, you think of this as this nothing in there. You kind of think of it as x to the 0.
Right.
So what would you do to that one? You have the 3.
X to
You'd raise it by
the
1.
1st over
Yeah.
1.
X to the 1 over 1, right? Which is just x.
Woo. Yep.
Good?
Is it just x?
Why did I get that?
Whoa, Nate understanding math? Something's wrong.
All right. So now if I take a derivative of this, let's say I was going to do that. Or all this, right? Just to double check that it comes out, let's take the derivative of the first term using the power rule. So derivative now. What would the power rule give me?
4x.
Mhm.
Wait, I forget how you do them with fractions, I'll be honest.
Well, you just leave that. You're just gonna drop the power by 1. Bring the
4x
power
raised-
down. Yeah, and that's still there.
Still over 4? Okay.
Okay.
4x.
And how about this one?
6x
squared.
squared over 3.
Yeah,
And
Plus 3.
plus 3.
2. Oh, wait.
Bam.
Oh,
That
okay.
last one was tough.
By that, this is just x cubed. This is 2x squared plus 3, which is what we had,
Dang.
right?
Dang!
Oh,
We're
huh?
good, man.
We're
This
popping
long
off.
weekend
Yeah.
could just
We
be
are popping
like,
off right now, you guys.
I mean, we're doing so good. This long weekend could just come early.
Now here's a
Disrupting.
you gotta pay attention to this. If
Might as well just play Minecraft right now. Just being honest.
Marvel, are you serious?
I was playing during bio.
Rude, Marvel. I mean, I can be doing that too, but am I? No.
okay,
Or
listen.
do I
to-
want to? Maybe.
Possible.
Just wait. You got a little time.
That's true.
So when we took the integral, we checked it by taking the derivative to get the same thing back again. But what if I had a +1 here, and I took the derivative of that thing?
Still in the trouble.
How would that
Oh.
change this?
You have your C plus C plus
We
C.
need plus C.
Plus C.
Yeah.
Yeah, if I took the derivative of this with the 1, it
Yeah,
would go away. If I had a 4, it would go away. If I had a 410,
Go away.
it's a constant.
But if it's a 1,
Oh, it's always
Which
gonna
is
be a
C?
C.
So the idea here is that I don't know if there was a number here or not, so I have to put a plus C.
Right.
Every time I do an indefinite integral, I got to put a plus C.
Do we need to put it at the end too? Like the last one?
always will.
Well, if I take the derivative
Always.
of this, if I take the derivative of this line,
Mhm.
the derivative of a constant is 0, so I would, I don't have to write that.
Haha. All right.
So it's because, the integral tells you what you took the derivative of to get that, and there could have been any constant there, and you still would have got this, so you can't know if there was a number there or not. So you put plus C, and you just don't know. All right? All right, so
I'll just start writing plus C for all of my answers.
what's that?
I said I'll start writing plus C for all of my answers. It's
Yeah.
something.
Well, if there are no limits of integration, then yes, yeah, you need a plus C on all of them.
I'm at like,
Nice.
Oh, and all your other answers, like,
yeah. Like on the test, if I don't know how to do something, just a plus C.
there you go. All right. So let's take another one of how about that one?
So you break it up again?
Yeah.
Yup, yup.
Okay. So then do your inverse power rule.
Let's think of this as
Right.
x to the half, right?
X to the 3/2
Yeah.
over 1/2.
No.
Over 3/2.
Over 3/2, which is the same as multiplying by the reciprocal.
Mm-hmm.
Is that okay?
Sure.
And Possibly. then
So your next side,
it'll be
you've got your 8x. Oh, wait. Inverse power rule. Never mind. You got your
2x to the power of 5
Yeah.
over 4
No.
Oh.
or 5. 5
We're not done yet.
plus C.
What?
There you go. Got it?
Yes.
Yeah.
Kind of, yeah. Plus C.
Good, good, good. Now,
So far, it's a good weekend.
Yeah, I know this weekend it could be a lot better if we had another 30 minutes of a weekend.
Oh yeah.
could be.
Could be. Could be, would be, should be.
I mean,
break it up again.
Break it up again. So remember, this is the antiderivative. It gives you the thing that if you took the derivative of it, what's that?
Cosine.
Derivative of cosine, does that give me sine?
No.
Negative sign.
Yeah, so I need negative cosine, right?
that was close.
Oh, I got the negative.
It would be just e to the x.
Yeah, it's just e to the x, right?
Plus c.
Let's see.
Oh, yes.
Oh my gosh, this is too easy to the test.
Yes.
So easy that we can keep doing it for the rest of the year.
Feeling accomplished.
Mission
Yeah.
accomplished.
Good, good. All right. Yeah, that's good. What other functions do we normally do? We do the trig, exponential.
We do.
That's it.
Oh, last time you said you wanted to talk about arc.
Arctangent.
Yeah.
We won't start that today.
Woo! Let's not do something hard online.
Absolutely fine with me.
Yeah.
Do you guys know what about this one? This one's a little tricky.
Towel's thrown in.
No, this is easy.
Oh, it's not bad.
You could try to think of this as x to the minus 1, right?
Yes.
Yeah.
Now,
We
if I use
just
the inverse problem,
So then it's x to the 0
It could just be x or 1.
over 0. And you can't divide by 0, so it's
do that, right?
illegal.
So that's
Fine.
So it's error.
It's not the answer.
To be determined.
Oh, wait, like you can't. Like it's not the answer. There's like
There is
something.
an answer. Do you guys remember what if I took the derivative of it would give me 1 over x?
Yeah.
No idea.
If you take the derivative. It's got to be. Wait.
Do you have your derivative sheet?
Is it not x?
It's the derivative of x to the 0.
No.
But that's illegal.
That'd be 0 because that's a constant. That's 1.
Right, but your 0 would pull down and then it'd become a negative 1. But then you'd still be multiplying by 0, so it'd be 0 again.
That's right.
So it's 0?
Do you have your derivative sheet?
No.
Not on.
It's not my open.
Let me look it up, you guys.
Bell,
Go,
oh, never mind, Bella. He's already there.
Oh,
He's already cleaning up.
Wait, hold on.
Legal.
Is it natural log, absolute value x
Natural log.
plus
Yes,
c?
natural log.
Oh, I am disgusted.
Yeah, well.
Oh, that was on the tip of my tongue.
But that's terrible.
Google.
So what do you log?
Oh, you just typed it in.
Yeah, I just type it in and entered your calculator.
Even that
So
calculator.
Will's still cheating?
Always.
What was Ben cheating? What are you talking about?
I said still, to be fair.
Good. All right, I'm just going to show you one new thing just to kind of preview it. We'll go over it next week.
Ooh.
Wait a minute. I gotta write this down.
These were hopefully the easier integrals. They're ones you can do right away.
That's enough for me.
You might have
That's what he's throwing the towel.
Would there ever
this
be
was supposed to be easy.
another absolute value one? Like we did one like that, but with limits.
Yeah, there could be.
Can you just take it off the test?
I probably won't do a lot of those, but
Okay.
How about none?
okay. So back to these. We'll do maybe 1 and 2.
1 and 2.
So that's 3x squared. Let me pull
1, negative 1.
it over to this other side so I can see it. And then I will write it. Now this one's a definite integral.
Yeah.
Let's just do it as an indefinite integral. We'll just, instead of calculating what the number is, we'll just say plus 3.
Yeah. Let's see.
That sounds bad.
3x squared, square root of x plus 5 dx. All right, that's oops. When I click, it closes that thing.
Can you separate products or no? You
What's
separate. Can you separate products?
This one's a tricky one. So, yeah, you've got a product, right?
Yeah.
So what we're going to do is we are going to rewrite it. So instead of being in terms of x, it's going to become in terms of what we call u. It's a different variable. So this is called U substitution, and it's our first method for solving integrals we can't do just straight away. So what we do is we realize that I've got x, right? I've got x in a few different places, and I've got dx, and I can't really do this integral right away. But because I got two parts, I've got two products, right? A product of two things. It'd be easier if I didn't have that. So what I can do, if I can see it, I've noticed that, I'll do it in like a separate color, that this thing is an x cubed function. And if I took the derivative of that, I would get 3x squared, right?
Yeah.
Which is sitting on the outside here.
Coincidence?
Weird.
Yeah, not well. This is where this method can help. When you see part of the derivative outside, the number could be off. The 3 didn't have to be here, but as long as there was an x squared, you could do this. But this one happens to be pretty convenient. So what I'm going to do is I'm going to say define my u as x cubed plus 5. So now I can substitute that function out for the square root of u. Okay. But I have that 3x squared dx. So what I'm going to do is I'm going to use implicit differentiation on this line. And I'm going to say derivative of u is du. And the derivative of the right-hand side would be 3x squared dx. And you'll notice I have 3x squared dx outside of the function, right? So I can replace 3x squared dx with du. Now I have a nicer integral. Is that okay?
Yeah.
All right, so what I'm going to do is I'm going to think of that as the integral of u to the 1/2 du. And now I'm integrating in u, so but it works the same as x. What would that give me?
When you do it.
Yeah. We just did the square root of x. It's the same.
So you'd have your negative. Wait, no. You'd have
x3 plus 5 over 2.
u to the 3 2 over
Yeah.
3 2.
Over 3 2, which was
Oh,
10.
I'm still wrong.
Yeah, you were
Right.
wrong. It's okay because I was right. So
Is that okay?
It equals out.
yeah, exactly.
You guys follow that?
Yeah.
I need the plus c, of course, because I didn't put if I used the limits of integration, then I wouldn't need the plus c, but I took those out, so I'm putting in the plus c. And now all you have to do to finish it is to put in what u was. So this is actually 2 times x cubed plus 5 to the 3/2 divided by 3 plus a constant.
Cool.
Is that okay?
Yeah.
I'll let you write that down if that's what you're doing.
Well, I'm writing it down.
Wait, when you have your f u to the 1/2 du, and then that becomes what we wrote down. What is the du? What does it do?
dy.
It's you're integrating with
Oh, okay, right.
in the variable u. I'll explain more how to think about that.
Yeah, I would say we're probably going into Wednesday. I'm definitely going to need a refresher on this, 100%.
We'll get a refresher. Maybe not tea, unfortunately, but
Oh,
Well, that's not a good refresher.
Oh,
I guess we will.
are you guys okay with that?
Yes.
For now.
All right. Let me.
I definitely like this a lot better than the graph.
Oh, the graph was no bueno. Except I was doing it in my head somehow. I couldn't tell you how.
Yeah, you and Will were doing really good.
Yeah, I was like,
I was like, right.
All right.
I'm like, I don't even have my calculator. I'm not even writing this down. And I was like I was just going off of Will. Will's like, I got 9. I'm like, no way. I definitely totally got 9. I'm like, yeah, Will, talk that. Because I'm with you. I agree.
So are we doing number 2?
Yeah.
Is this another you question?
Yeah. So let me switch here, and then I'll go back.
Okay. So do we have to find the derivative of the inside first? No, that was
Is it
Yeah, we
possible that we do it on calculator?
I'm sure any calculator can do all this stuff. But
So Will's like, yeah, I need a calculator.
Yeah, but I plugged it in, like without the limits. It's not
there's
giving
no
any.
limit. Oh
Yeah,
yeah,
I mean, yeah.
maybe with the CIS model, that's computer algebra system.
Uh-huh.
I'm not sure that every
I
model would.
get the integral.
All right, I guess.
Where
I
is
did my head.
Wolfram Alpha will do it. I mean,
Oh, I'm looking for I in my catalog.
so notice there's something outside of the raising the thing to the 5th, and then there's something inside. Think of taking the derivative, right? Which one, the inside or the outside, which one is the derivative of the other or close to it?
It's the
X to the 4th,
Is the,
closer to
4x3.
yeah.
then you
yeah,
have the X3 at least.
5x to the 3rd.
Correct, yeah. So I'm going to say u is going to be 2 plus x to the 4th. And then if I take implicit differentiation, what do I get?
One second, I got lost.
4x3.
Yeah, du
Equals to 4x3.
Okay.
dx, yeah. When you do implicit, you always got to do the little chain rule on x and put a little dx.
Okay. Hopefully I remember that.
What were we supposed to remember?
The DX.
When you do implicit differentiation, you bring the 4 down, drop the power, and then it's like chain rule, the derivative of what's inside, you got to multiply also by dx.
Okay. Got it.
So this will, if I rewrite this, I will see that dx is equal to 1 over 4x cubed du,
Whoa.
right?
Yeah.
Cool.
So I can rewrite this as the integral. I got x cubed. I'm calling what's inside u. So that's u to the 5th. And instead of dx, I'm going to put this stuff, which is 1 over 4x cubed du. So I see that the x cubed is kind of go away.
Oh, I love canceling.
So this is the same as 1/4 of u to the 5th du.
Wait. Oh, yeah, the one for Kim. Oh, never mind.
Is that okay?
Yeah, I get that part.
Back in.
So how do what's my integral here? I'm going to have the 1/4.
Mm-hmm.
It's u power 5. It's a big number.
Yeah.
Like, really big.
Or do we have to like do it?
Yeah, take the integral of that.
Oh my.
I don't remember how.
I trust in Will.
Inverse power rule.
Okay, that's of the whole thing.
is that the
2 to the 2.
No,
Wait.
just here.
Just where?
Yeah, the U5 though. So
Oh,
2 plus 4x parentheses,
Oh, no,
power 5.
we'll sub in later. Just in terms of
U6
U.
over 6.
Yeah, U6 over 6, right?
Yeah.
Wait, why that?
It's what we were doing before.
It's just like how you do
Oh.
but we're
Then-
integrating in U, so we do the same to U as we did with X before.
Wait, so 1 over 4 is time U6 over 6.
Yeah.
Yeah.
Okay.
So altogether, that'll be 1 over 24 times U happens to be 2 plus X to the 4th. That all will be raised to the 6th plus C, plus some number.
Is that it?
Yeah.
Perfect. Break time.
There's no way I'm gonna be able to do that on a test. That's all I know.
Well, so this isn't integration by parts. Integration by parts is a little bit more involved, but this is called U substitution. It also involves a U. It's our first technique that we're learning.
Is there an easier technique?
This is the easiest.
Whoops.
Towels thrown in. There's no way.
They only get harder.
Unless the other ways make more sense.
Life only get harder, Nate.
Yeah, well, I get it. Life is hard.
I have something to show you though.
Some math memes.
Yes.
And then the Yoda ASMR.
Actually, it's a physics meme.
Speaking of physics, did you guys finish the FET?
No. Oh, yeah.
Yes.
Yeah, I did. Like years ago.
Okay, because I did not.
It was due yesterday.
Do you guys know the story of Newton and the apple?
Well, you see,
Yeah.
Maybe.
Apple fall on Newton. It fall.
And he was like, it was during the plague of that summer where he had to go to the country house to stay away.
Right.
And he invented calculus and physics.
And then
the story was, he came up with universal gravitation when an apple fell, and he asked, why does the moon not also fall? And he kind of figured out the connection there and came up with all his theories.
I don't know what he was smoking, but I want it because there's no way he discovered that just by an apple falling.
I love this.
Nate, why does the moon not fall?
What's this? Anyway, I literally
That's
just
probably how it happened.
Turns and looks at the apple.
yeah. I love how it just freezes there and he just like stares at it. Like, huh.
Gravity was discovered then, but people.
Gravity doesn't really exist.
Before 1687, gravity.
People are just floating around.
Yeah.
All right. Well,
Free weekend.
I started a little early.
Long weekend. Woo!
Yeah.
Ooh.
Any questions
Extra.
on this stuff?
20 minutes.
All right, then you can go to sleep, Griffin.
Griffin, you can follow. Griffin, dunk it for me. Dunk.
I don't
Right
even know
now.
where the basketball is. And last time I tried to dunk on a hoop, I broke my foot. So I will not do that.
Touch the rim, then. Touch the rim for me.
I can't. It's too high.
Oh my God, you're so Griffin.
Unfortunate.
All right. Well, you guys enjoy your time off, and I will see.
Oh, I will.
You too.
Goodbye.
Adios.
Bye.
Bye, guys.